In talking about stellar evolution, I want to talk about Algol. We've mentioned Algol several times. Algol, it's Beta Persei. Algol stands for Arash Algol, the head of the demon. So this was the head, the Medusa in mythology, being held at arm's length by Perseus. It's also famous for being an eclipsing binary, that every few days it dims down and then it's bright again. And so to the ancients, that was a sign of bad things happening when the star got dim. So we want to study this, a little bit more, and we look at it. We now have the ability of finding the spectral types of each one of those stars. Now, the odd thing here is that we have found that we have two stars here. The primary star, which is the brighter one, is a B8 main sequence star, and so as it's a very hot, very bright star. The secondary star is a K2 giant star, so a red giant. Now, the size of the star does not really have a whole lot to do with the mass of the star. As stars die, they expand. They get really puffy when they expand like that. So as they die, they can expand, become puffy. They don't really gain mass. They just get fatter, bigger. Well, the B8 star turns out to have a mass of 3.6 solar masses. The K2, the red giant, has a mass of 0.8 solar masses. Well, what's wrong with this story? Well, we've learned here few lectures ago that the lifetime of a star depends on the mass of the star. The higher the mass, the shorter the life of the star. And yet, in this system right here, the low mass star, the 0.8 solar mass, that's a red giant. That's a dying star. Okay. Whereas the B8 star, the high mass star, the 3.6 mass star, that's still in the main sequence. The 5 there means main sequence. So that means it's not dead yet. So what's going on here? We have a low mass star that's off the main sequence orbiting around a high mass on the main sequence star. So when the big cool star passes in front of the small hot star, it gets really dim. And then when it passes behind, well, we lose a little bit of mass from there, but the bright star is so bright, you don't lose a whole lot of light there. So you get a light curve that looks like this, in that it gets really dim here when the red giant passes in front of the B star, and then it gets a little bit dimmer when the red giant passes behind the B star. So, and then it gets dim again as it passes by. So what's going on? Well, this doesn't make any sense at all, because we know that the low mass star should be living still, and the high mass star should be one that died. Well, artist's impression, what's happening here, though? The high mass star is the small thing here that's still well inside of its Roche lobe, whereas the low mass star has filled its Roche lobe and is dumping mass. It's dumping mass onto the other star. So it's dumping mass onto that high mass star. Well, there's your hint. What probably happened with Algol is that after they formed, we had probably a high mass star and a low mass star. As the high mass star lived quickly and died, it expanded, filled its Roche lobe, and mass started pulling off. Now, what kind of mass? it's going to be the mass on the outer parts of the star. Well, what's on the outer parts of the star? Well, the core is fusing hydrogen to helium. What's the outer parts doing? Very little. So the outer parts of the star stay mostly hydrogen with a little bit of helium in there. So we're dumping hydrogen onto the other star. Well, that causes that star to have to as it gets bigger, gravity gets stronger, and so the fusion in the core has to speed up in order to balance the weight of all that mass we're adding to it. What that does is that means that it goes from being maybe a G-type spectral type or whatever to being an F, an A, up to a B. Whereas the original star, which might have been, you know, an A or a B, and then it left the main sequence, has lost so much of its mass. The outer layers all bled off into the other star that it now has less mass. So what was originally the high mass star is now the low mass star. And what originally was the low mass star is now the high mass star. So that's what happened when you have these binary stars that are very close together. That explains Algol.